your own backends for frontends or to collaborate with your server-side teams so that you can empower yourself and your mobile teams to provide better backends for yourself. So why Ktor? Well, as Android developers, or a lot of you might be Android developers, you are already familiar with Kotlin. And if you're using Kotlin on Android, then you are also probably familiar with coroutines. And things like concurrency, topics like concurrency are extremely complex. So already having this knowledge available to you is a huge advantage. And if you are working with Kotlin in your day-to-day job on a front end, then Ktor will feel extremely familiar because it's a Kotlin first framework. It's built on top of coroutines, and therefore it should feel very familiar to what you're already used to from Android. What I also think is really great about Ktor for mobile developers is that it's very unopinionated in the architecture, right? So it allows you to reuse and maximize the transfer of your existing knowledge from mobile to the server side, but also the other way around. So all the new things you learn on the server side, those are all things that you will also be able to rely on in the front end, as you stay within the same language and same ecosystem of frameworks and libraries. So I'm going to talk about a bit of an agnostic kind of architecture, but I hope this is very familiar to all of you. This is kind of like clean, where we have the pure domain on the inside, then we have interfaces outside of that, and then we have our platform code or infrastructure code, testing, activity application, UI routing, and the dependency or the direction of the coupling goes from the outside to the inside. That means that our domain cannot rely on the Android framework, for example, but when we are writing code in the UI layer in Android, we can rely, or we should rely, on the domain of our business logic. And I want to start by talking about the application. And as you might know, on Android, the application starts, it goes into the manifest, and then it starts some activity. And that is how we build our applications on Android. So what does that look like for Ktor? So we are building a regular Java application. So all that we need is a main method. And inside of that main method, we can start an embedded server. In this case, I'm using the Netty engine to run the underlying networking engine. And that Netty is the most used network engine on the GVM. And here we are starting our server on localhost, so 000 on port 8080. And it's important to remember that if you want your Android emulator to connect to the server that is running on your local host, you need to provide the IP address 10.0.2.2, as that is the IP address that your emulator will redirect to the local host. So how does Java know which main function to start? In Android, we define the activity in the manifest. On Java, we define the main class also in the manifest. To do so, with Ktor, we can just rely on the Gradle Ktor plugin that gives us access to the application DSL, which allows us to set the main class. And what is important to note here is that if we have defined the file as application.kt, then the class is called application KT. So remember that KT postfix is needed to direct to the class that is generated for the Kotlin file. And if we have that set up, we can simply call Gradle run, and our server will start. But of course, we are not going to be running our application in production using Gradle. So one of the ways you can do this is by building a fat jar. And the fat jar also comes out of the box from the Kotlin Gradle, the Ktor Gradle plugin. And here we simply define a name for the jar. And once we have built the fat jar, which includes all of the dependencies, we can simply launch the jar using the Java CLI command line tool. And while this is really interesting for running a jar in any environment that supports Java, it is often also not what we want to do in production, right? We are here at the Google developer group, so we want to deploy things to Google Cloud, of course. So for that, we can again rely on the Ktor Gradle plugin. And if you're not familiar with containers or Docker, that doesn't really matter because you don't have to be. The only thing that you need to know is you need to configure a name for the container and a version so that Google Cloud can know which container and which version it needs to deploy. And then we need to provide the project name, which is the project name in Google Cloud. We provide the app ID, the username, and the password, and we can then upload our application to the Google Container Registry, which can be used to directly deploy your application to Google Cloud, right? So this is a very simple way of publishing your applications from from the CI server to Google Cloud, and then with a single click or with an automated process, you can roll out this new image or this new container that was uploaded directly to Google Cloud. So deploying your application to Google Cloud is relatively simple thanks to this support in the Ktor plugin. So where was all this coming from? I think this is a pretty neat feature. Ktor exports a version catalog, so you do not have to define the entire version catalog yourself. You can just import it in the settings Gradle file. And then you can rely in your Gradle scripts, you can simply rely on the version that is now available to you in your project. And here is the dependencies that we're going to be using today. So we are going to create a Netty server that has some YAML configuration. We are going to set up authentication, and we are going to be doing some CRUD communication using Kotlin JSON. So configuration. When we Android application, we built the APK, we upload it to the Play Store, and that APK gets distributed to all of our users. So if we have dynamic configuration, for example, the API URL, we typically define this in the build config, and we have a different value for the development flavor and a different value for the production flavor, and so on. It's not great, but we have to bake the secrets into the APK that we distribute. That is not the case for the server side. On the server side, you have complete control where your application runs, so you can prepare the environment in whatever way you want. So here, we define a dynamic port and host that we need our server to run on, and we define that if the host or port environment variable is available, it will take precedence. If it's not available, we will use the fallback values. And what is actually neat is that if you deploy this application with this configuration to Google Cloud will contain the correct host and port that you need to run your application, so you can actually use this configuration to correctly run your production applications in Google Cloud. So how do we work with these values? Well, we can very easily load the application config file from the project's resources, and it will automatically load the environment variables where and when needed, and we can simply turn that into a data class that has the same key value pairs as our application file. Right? So this is quite straightforward. This relies on Kotlin serialization to go from the application YAML or HOCOM file to our typed configuration. So as I already mentioned, multiple formats are supported. And once we have this value at runtime with the environment variables loaded, we can now properly pass the host and the port to our embedded server so that we are no longer always running on localhost and 8080, right? So this is what you could consider a production-worthy entry point for your Ktor application. And this is also a perfect place to split your application. And the split that we're going to be making is, as you can see here, the lambda of our embedded server takes a suspending function with an application receiver. And we are going to define the exact same function. So we define a suspending function, which is an extension on the application. It takes the configuration as a parameter. And this is the function that we will use to describe our entire server. Why make this split? Well, we do not want to hard couple our server to how the server starts, such that we can run that same application function in a testing environment. So here I'm using the testing support from the Ktor library. We start a test application instead of an actual server. I'm calling this same app function that we were using here in production. But we are now running with an in-memory server, which is extremely fast and which can be used for unit testing, right? So all the code that we have seen up till now that was related to our production environment, all the other code that we're going to be seeing now is our, let's say, Ktor infrastructure, but we want that to be unit testable, which you can achieve thanks to this framework. So there's more that we need to configure than just host and ports. We need to configure how our application behaves. And before we dive into that, let's very briefly see how Ktor works. If you are familiar with how HTTP clients work, like OKHTTP, then you might be already familiar with the interceptor process or the interceptor pattern. And on a server, this works pretty much the same. You have an incoming request, and eventually that results in a response. And in between, we have a couple of blocks. So we have the routing block, which is defined by Ktor itself, and it makes sure that the correct function is called. Then you have potentially any plugin that can be installed before the request is handled. The request gets handled, and we can do something after the request was handled, right? So we can intercept before and after. We can wrap handlers. And actually, the entire Ktor framework is built this way. So everything that you will find in Ktor is a plugin, including the routing support that I just mentioned. So everything in Ktor is a plugin, which makes it extremely flexible because you can plug and play features. You can replace features that come out of the box with specific functionality that you might need for your use case. So that brings us to configuring Ktor. And what did I mean by that? Well, Ktor is a very lightweight framework. It is unopinionated, so it makes no choices for you, not even how it serializes and deserializes JSON. So in this example, I'm configuring content negotiation to work with colonic serialization JSON. But if you are using Moshi, for example, if you prefer Moshi, that also works. There's also support for Jackson or for JSON. So whatever framework that is best for your use case can be plugged in to Ktor, and there's support for a wide range of frameworks out of the box. Another very useful plugin that I wanted to mention is the call login plugin. And the call login plugin gives you very detailed tracing in what's happening in your server. And this is especially useful if you get lost or you're not sure why your handlers are not being called or why requests are getting lost. And here you will get a complete trace of how the requests are being handled and which handlers are not being called and which ones are. But that also results in a lot of logging. So I typically do not enable this in production. So I check the development mode flag to only enable this in development. And then finally, I wanted to show two more plugins, but we have more than 100 plugins in the Ktor ecosystem right now. But the server-sent event and the WebSockets are becoming increasingly popular with LLMs and agentic frameworks. Pamela just mentioned Coog. Coog also has support for streaming. So this is becoming more and more common to provide very nice user experience. As you know, is super important. You cannot just show a spinner for 30 seconds. So you need to show something by streaming these responses in a meaningful way to the user. So that is more or less how you can start and configure a simple Ktor application. So that brings us to infrastructure. And I wanted to briefly mention infrastructure because it's a bit different from Android. With infrastructure, we typically mean databases and repositories. So repositories are exactly the same as on Android, so it's not worth covering. Databases are slightly different because the database for a server never runs on the server itself. Like on mobile, the database runs on the mobile device. With a server, the database is almost always a remote instance. So we connect through an URL, a username and a password. We define a data class for that. And we then also define the configuration for that, because we need to dynamically load the secrets when our application starts. But it's also very critical is an Android application or a mobile application as a single user, which has different problems. The server, what you need to take into account a little bit is that you have many users, right? So in the case of the database, we need database connection pooling, right? We need pooling such that the connections are more efficiently reused, similar to dispatcher pools like dispatcher's default, but then for connections to the database. There is a single framework in the JVM that everybody uses, which is the Hikara data source library. It is extremely simple to use. As you can see here, we just pass the URL, the username, and the passwords. And that brings me to exposed, right? So the data source doesn't really do anything by itself. We still need something on top of that, like exposed or SQLite or any other JVM frameworks you might prefer to actually use the database connection pool to connect to the database. And as Android developers, I expect you to all become very wary now, because we are connecting to the database. If you are on Android, you know about lifecycle. You've spent a lot of your time thinking about lifecycle. Luckily, on the server side, it's quite simple. The server starts, it runs, and then it stops. So the only thing we have to do is we need to register a listener to say when this application stopped. We need to unregister and close the database and the data source. And that's pretty much all there is to it. I will come back to lifecycles later. Again, this is, I think, might seem controversial for an Android developer, but on the server side, it's considered extremely bad practice to mock or stop the database. The reason for that is since 10 years ago, there's a library called test containers, which has become extremely popular. And test containers allow you to very efficiently and very fast start an actual database. To give you an idea, I can start about 20 databases on my machine in under a second. So it is really not a bottleneck to not use an actual database. And there's many solutions in case you run into problems. There's a cloud environment where there is always instances available if you really have such an extreme need. But you can also reuse instances, and then you have zero startup time. So if you are working on a server side, I want to explicitly push you to use a real database using test containers, because this is typically also the most critical part of your server-side application. So how do you use test containers? Well, using test containers is extremely easy. It is safe to capture a test container in a top-level global static property, right? So you can define a global static singleton. You can start the server, and that's perfectly fine. The reason for that is there is a concept called Ryuk, which is inspired by a character from the Death Note anime. And what this does is it keeps watch over all the containers that you started. And when the JVM shuts down, so when your tests finish, it will make sure that all the test containers automatically close so that there's never any leakage, right? So test containers out of the box make sure that you never leak a container, so you don't have to worry about that at all. So we've seen infra, we've seen start our application. Let's briefly talk about the UI. And as you might know, UIs on the front end are very complex, right? If I look at the screenshot from the Kotlin Conf application, I can see there is an image that needs to be loaded asynchronously. There is a workshop in the list, there's a talk in the list, there's bookmarks, there's profile information. Hopefully, all of this data was available. Hopefully, most of this data came from a single network call. But I think that if you're doing Android, I'm pretty sure most of you have faced a situation where you have 3, 4, 5, 6, or even more network calls to build a single home screen. It's an absolute nightmare. In those cases, please feel empowered to build your own backends for frontends after this talk, and build yourself a backend that only requires a single call for your home screen. Building UIs, well, there's no UI again, so what do? We do still have some kind of what you could consider a view, right? So we get input from the user, and input comes from the user with a request and an HTTP method. And this HTTP method kind of tells us what to do. So here are the 4 popular methods: post, get, put, and delete, and they form CRUD, create, read, update, or delete. I'm not going to go too detailed into that, but then we also have our responses, right? So this is what we show user. We give them a value and a status. In the 200 range, we are communicating that everything is good. In the 300 range, everything is good, but something moved, right? So these are redirects. Something was moved permanently to a different URL. Something temporarily moved, so I'm going to redirect you. We have client errors, right? So I think these are the ones that you're most familiar with from Android. A form was not correctly filled in. A parameter was missing. You do not have the correct authorization to use this URL. You tried to get a value, but it was not found, and so on. And then we have the server-side errors. And typically, we don't really deal with these in our application because we typically only return 200 or 400 ourselves. 300 and 500 are typically taken care of by the infrastructure, by Ktor itself, or by the environment. So how do we define these routes? Well, everything in Ktor is a DSL, and the DSL always starts at the application. So we again have an extension function on the application class, and inside we can define our post, get, put, and delete methods. Here we can see that I have to repeat this user prefix, but we can also group them in common layers. So you can split your code using your DSL however you prefer. So we've reached the point that we are not of a route, right? So we have an incoming request. What can we do? Well, we can receive the path parameters using get or fail, which means give me this user ID, or if it's not present, send a bad request to the user. You can retrieve query parameters, and that allows you to retrieve not only primitives and enums, but also collections, right? Because it does not make sense to support more complex type. You should never put JSON inside of a query parameter, so only simple types are supported. You can access headers, you can access cookies, you can access anything that you might expect from an incoming request. When we have gathered all the information from the incoming request and we have validated everything that we needed to validate, we typically delegate our code now to the interfaces layer or to the layers that contain all our business logic. When we have received the result from our business layer, we send a final response to the user. In this case, okay, we found the user, here is the user. And in other case, when the user was not found, we return not found status code. So I hope that gives you somewhat of an idea of how you can create a server, connect it to a database, and handle some incoming requests. I don't want to go too deeply into the business domain because this is exactly the architecture as you have it in Android, except for a few models maybe. So we define some data classes in our domain. Here, there is nothing with a dependency on Ktor or Hikari, anything from our database. This is pure Kotlin code that describes the domain of our business. For example, here, upserting a user. Upserting is similar to insert or update, and then the inserted or the created user. And then we can use that in our interfaces layer to say, hey, here with the repository, we have our operations. And again, you can see here that nothing from Ktor or any other platformer SDK types appear here. So this is purely business domain, exactly as how you would define it on Android. I want to very briefly show you how you can use that to, or how you can use Exposed to implement those repositories. And in Exposed, we define our tables or our data all in Kotlin code. So here we define a simple user table, which has a unique identifier of type long with the name user ID. We have an additional single unique field subject, and then we have a couple of nullable fields, right? And this table represents a user that I am authorizing with Google. We, just like on Android, we create a class that holds the dependency, implements the interface, then implements the function. We want to make sure that everything runs on the correct dispatchers. Just like SQLite, in case you're familiar with SQLite, in Exposed, you always need to wrap your DSL functions in transaction. Here we have our SQL DSL. So on our table, I'm going to call the upsert returning function. For those that are not familiar with upsort and returning, this is something from Postgres where you are either inserting a new user or updating an existing user in case of the conflict, which is in this case on the subject key. When the user is inserted or updated, then return the entire row back to us so that we can continue processing the data. So in the case that there is no conflict, so in case the subject does not exist, we are going to insert the subject. Otherwise, we're just going to return the existing user. And Exposed SQL DSL works over collection APIs. So it gives us an iterable of result row. Since we only have a single result, I'm extracting that using the single collection function from the Kotlin standard library. And then I'm going to transfer my result row into my actual user. And we do that again with a type DSL from Exposed. And here we can, for example, see that we can assign to our user, and the values that we extract from our result row are the types that we had defined in the original table. This function that we see here is purely boilerplate code, and it's something that we aim to remove by the end of the year, right? So we aim to remove the need for this boilerplate code soon in the library. And just like we're doing on Android, and this has many different names, on the server side, we very commonly name these services. And in services, we typically orchestrate or combine different repositories to provide higher level use cases. I know on mobile, they're also often called use cases or orchestrators. So these are all the same things. They are interfaces that define behavior that consists of multiple interfaces. So now putting everything together, this is our entire application that we've written up to now. So we have our database that we connect to. We create the user repository with our database, right? And notice here that we are encapsulating the actual implementation. We install some plugins, for example, for our JSON, and we then create or install the routes using our interface. So I hope nothing here is too shocking for all of you. This should feel very similar to clean architecture or similar that you're using on Android. That brings us back to lifecycle. And I know 10 years ago, you could not go to any conference without seeing this Android activity lifecycle image. I hope that's not the case anymore, but I'm pretty confident it's still relevant. Luckily, on the server side, like I said, it's much easier. Our server starts, and at some point, our server stops. And in between, our server is just processing incoming requests. And that allows for something very cool. It allows the Ktor application class to implement a Coroutines scope. And the Coroutines scope is active for the entire lifecycle that your server is running. And that is really, really powerful, because that means you have a Coroutines scope that lives for the same life cycle as your entire application, so you can just launch things on that scope and forget about them. They will correctly be closed when they need to, when the server stops. I can imagine this is something I would have wanted on Android 10 years ago, but yeah, that's why I'm on the server. So how does this actually work? Our application starts. The routing plugin gets installed. We have some incoming requests, and the routing plugin is going to create a new coroutine for every request that it's processing, right? So we can have many, many coroutines in parallel, processing many, many requests. What if something goes wrong? Well, we send a 500 internal server error to the user. But does our server stop? Luckily not, right? Because our application is a supervisor job. So our application supervises all the ongoing requests, and if something fails, it will send a 500 internal server error to the user. It will log the exception, but the server will continue running. So that's pretty cool. So what happens when the server at some point needs to stop? Let's say that Google says your task is done, you need to shut down. Well, then Google Cloud is going to send a signal to the application. The application is going to gracefully stop, which means it's going to await all the in-flight requests to gracefully finish, provided the grace period, and then it's going to start stopping the application given the timeout. And this is also after all the requests were finished and our application starts shutting down. That is also when our Hikara data source from before will be closed, right? So only after ongoing requests are finished, then our Hikara data source will be closed. So this allows you to rely on cancellation signals of coroutines to figure out if your server closed, right? And that is extremely powerful. For example, here again, the example, when the application stopped, you can close the data source. And this is really simple because you don't have to take into account that the server could potentially start again. Once the server is stopped, it will never start again, unlike activities. So what do you do if you need a coroutine in your business logic? Well, it's quite simple. You can inject the application coroutine scope into your business layer, but please make sure to always properly encapsulate the application. So don't expose the application to your business logic, but instead expose the coroutine scope itself. Prefer to inject that into the constructor and then rely on it in your business logic for your long-running tasks. So to wrap up, we still need to protect our server. And I hope most of you have used the Ktor client on Android. If you have, then you can use the Authentication plugin to automatically load and refresh OAuth tokens. Perhaps you're using OKHTTP and you are using the OKHTTP authenticator that allows you to do something similar. The point is that, especially for mobile applications, the mobile application is the one that is loading the token directly from Google. So the server doesn't have to do anything except for verifying that the token is correct. So how can we do that? Well, it's quite simple. We just configure JSON web keys to the Google instance, which means we need to specify Google is the issuer of the token, and we need to specify the certificates that Google uses to sign the token. And then again, we can configure authentication using the Ktor DSL. So we create an extension function on application class. We start the authentication block. And inside of the application block, we are going to define a JSON web key provider. And the JSON web key provider is the builder that connects to the certificates of Google. And we're doing so with a cache and a rate limit so that we're not spamming Google's server. And then we can use that as a verifier, right? And that is automatically going to check that if we have an incoming authorization header, that the token in the header was signed with Google's private key, that the issuer inside of the token is actually Google, and that the token was not expired, right? So if we set up this very simple authentication block, you can now be sure that every incoming token that you receive is actually a token, a valid token from Google, right? So we have to do very little on the server side to validate these tokens from Google. There's, however, one more thing that we can do is we can refine or provide a nicer type of authentication to work with. So we can validate the incoming credentials. We can then, for example, say, okay, I know that Google never sends a non-null subject. And the subject is something that is critical for my business logic. So whenever I have an incoming token, I'm going to validate that the subject is not null. If the subject is not null, I can create my Google ID token with a not null subject, right, instead of a nullable subject. And I can return that from my validate block. If it is null, I'm returning null, and the user will see an unauthorized status code. But this allows us to, in our route, here we are now saying, if you want to reach this route, you need to be authenticated using Google. And inside of our block, we are going to get the Google ID token, which we just verified that was correct. And we can access now the subject in a non-null way, right? So I hope this is clear that with a very simple way, you can have Ktor automatically check with Google if the tokens are correct. So you don't actually have to implement verifying the tokens or checking with Google, getting the certificates. That can all be done automatically. I hope you liked my talk. I hope it was useful to everyone. You can find both my slides and the complete project that I showed today on the GitHub link at the bottom. But I would also be more than happy to answer any more of your questions. And also feel free to send me a message on Slack or social media if you have any very specific question you want to discuss offline. Thank you all so much for having me.
All right, Simon, can you hear us now?
Yeah, I can hear you. Yeah, I can hear you.
Okay, just before the live audience do their question, there's a question in the Q&A section. It says, does Ktor have first-class support for Apache Camel, similar to Quarkus or Spring?
I don't think there's first-class support for Apache Camel right now.
Okay, that has been answered. Alex. All right, let's take questions from live audience. All right, there was a lot of reference to Android, and I'm sure not a lot of Android developers here, probably a few of them. So, but it's all right. This presentation is recorded live, so you can always watch it and go check out what he keeps saying about activities and stuff. It doesn't mean like Friday activities, boogie down activities. It's a different reference. All right, any questions there? All right. All right, you go ahead.
Thanks for the talk. I'm not sure if you can hear me, but I just wanted to know if there's on the server side, is there the concept of dependency injection?
So dependency injection is extremely popular on the server side. In Spring, there's de facto dependency injection. Ktor has first-class support for dependency injection, but a lot of people prefer to use the frameworks they're used to Android. So Kotlin is extremely popular as well. And I know there's also some people using Dagger, potentially Metro might also become a good option.
Hi, Simon. Thanks for the talk. We had a question, I think you heard it at the end from the left field there regarding industrial systems. just out of the fun, I was interested now hearing your bold statements about the performance that you were expecting. Do you know of use cases where it's actually used in a high performance kind of settings? Of course, you were using the GCP provider and running it on Cloud Run, but like, I guess it could also be used on a shop floor level in industrial systems. Like, what are the use cases of the most high performance setting you know of?
So I cannot name all the names of the companies, but I know one of our biggest users has an extremely large microservices network, a couple hundred microservices or more, and they're processing billions of events with Kafka. So they have an extremely big platform that's used worldwide by hundreds of millions of users. And I myself have also worked on several very large systems. So I've been using Ktor in production, I want to say about 2018. And I've worked with teams where we had 50 or 100 microservices with high load. What is really nice with Ktor is, for example, if you compare it to Spring, in the sense of it being fast and performant, it uses the same underlying engines, right? So both Spring and Ktor are using Netty, right? So if there is any real performance issues, it's most of the time is a networking engine or a big bug. But I mean, we're so long in the Ktor ecosystem now that we've worked with a lot of people. We know some big clients that are using them, so we are very closely watching performance. So in this regard, we're doing pretty well. But what is really nice about Ktor is it's so lean. It's extremely fast to start. So if you have an almost empty server, it starts literally in seconds. So it's for this GVM, it's one of the fastest starting server out there at the moment, at least for the bigger frameworks.
Any more questions? All right.
First of all, thank you so much for the talk. It's really great. I just had some questions about deployment options when it comes to Ktor. What are I saw you talk about Docker at the start. Is that the only way, or can you do like maybe natively just do a deployment?
Well, I think Docker is the most used way. I mentioned here Google Cloud. The Google Cloud Registry, but there is support for the Docker Hub registry. There's support for Amazon. You can build the plain Docker images and upload them to your local Docker repository or Docker registry that you host inside of your company. So there's a lot of options. FatJar is what gives you the most flexibility, right? So if you need to run in a very obscure machine or a very obscure environment, then as long as you have the GVM available, you can run a FatJar in that environment. And this is what gives you the most flexibility to run anywhere. There is also support for Java applets, but they are not very commonly used anymore these days, but it does exist and it works. So you can also run it with JBoss or Tomcat if that's where you are running your applications.
All right. So if there are no more questions, Simon has some things to do back there. We managed to steal him for about an hour. If you still have questions, I think he left the contact details. So
yeah, you can find
always
me
reach
on
out to him.
you can find me on Slack or social media.
All right. Thank you so much, Simon, and hope to have you back again for another talk. Thanks.
Thank you all so much. Have a great day.
Yeah, bye.